Everyone, I hope you are safe and doing good. So in the series of learning C++ programming language, in the previous video we have seen arrays in C. Means we have discussed the concept of arrays, 1D arrays in C, right? The need of 1D array, what is 1D array, how to declare 1D array, how to initialize 1D array, how to, the memory representation of 1D arrays and how to access elements of those arrays. And based on that we have discussed 4 or 5 coding problems as well, lead code problem, right? So now in this video we'll see what are multi-dimensional arrays, especially 2D arrays, right? So multi-dimensional arrays are having more than one dimension, that is for sure, right? So you see how you declare 1D array, just write data type, right? Like this, int a array name and here size like 5. So data type, here we write array name and size of the array. That's it. This is how you declare 1D array. So now if you have more than one dimension, so you can declare, you can give like same data type array name, here size 1, size 2 according to the dimension and up to size n. How many dimension you have, that many size you have to give here, right? So like 2D array, 3D arrays, mostly we use 2D arrays, right? So now if I take like example of 2D arrays, so 2D array, it is the simplest form of multi-dimensional arrays, right? So how you declare 2D array? Same data type, array name and only two size 1, size 2, because we are having only 2 dimension, right? So which type of data to be stored, right? This is array name and here you can say the maximum element to be stored in that array, that size we give, right? Now first of all we will see like what is 2D array, but the need of 2D array we discuss first, right? So if I ask you, just declare, you have to declare an array in which I want to store marks of 15 students. Let's suppose in my class I have 15 students. So you simply declare an array of marks with name marks and size 15. Okay, fine. Now I say marks of 15 students but in 5 subjects. In each subject I want to store the marks of 15 students. So one way is what? Either I can say like marks, or you can say sub 1 for 15 student, then another array name sub 2 marks for 15 student, like this. And you just declare 5 arrays because you have 5 subjects, right? Now you have 5 arrays. But is there any simple way in which I just have to declare only once? Yeah, we can do this with the help of 2D array. Just add one dimension here only for 5 subjects. That's it. No need to declare 5 times the arrays, right? That is why we also say that 2D array is array of arrays, right? Because here we are 5 arrays, but in one array I'm going to declare this. So simply I can say like, how to declare that thing? Float, name of the array, 5 subjects and 15 students. That's it. Oh, you can also declare something like this. Maybe this question is in your mind like 15 here, 5 here. That is also fine. Okay. But the difference is what? I'm going to tell you. So here also 5 subject, 15 students, or 15 subjects we have, and each subject I have 15 students, and in 5 subject I want to store the marks, right? It's okay. Now so how we can say that this is row? So if you write the general syntax of declaring 2D array, then simply we write here data type, array name, and here we write row size, and the first one is row size, the second one is column size, right? This you need to take care. So in this case we have 5 rows, 15 columns. In this case we have 15 rows and 5 columns, right? First would be row size, second dimension would be column size, that is for sure, right? Now how if I declare this array, so how you think, like if I say how you can visualize this array, how this array is to be stored in memory? So generally we visualize this thing something like this, like rather than 15, let's take only 5 subject, and or we can say let's take a smaller number, 2 and 3 only, right? 2 subject and 3 students, that's it. I have a very special subject, 2 special subject in which I have only 3 students, like maybe I'm guiding PhD students, right? So now, or second way is here we can write down 2 and 3. So how you visualize this thing in memory? Sorry, not in memory, but how we visualize this thing. First is row size, so 2 rows. Column size, so 3 columns, something like this, right? And index would be start, array index start from 0, right? So 0, 1, 0, 1, 2. These are rows and these are columns, something like this, right? This is how we see. So we can say 2D arrays, we can also see this in a matrix form or tabular form, right? It's nothing but a table, or we can say it's like a matrix also. Matrix is something like this. So in matrix also we store data something in this form only. So that is matrix also, right? Now if you want to access the element of 2D array, then we need more than one index. In 1D array we need only one index, there's 0, 1, 2, 3, 4. But here if you want to access this element, you need 2 index. Which row and which column? You need to specify 2 things, which row and which column, right? So row index is 0 and column index is also 0. For this element, row is 0, column is 1. For this, 0, 2. For this, 1, 0, 1, 1 and 1, 2. So more than one index you need. Basically 2 index you need if you are accessing any element from 2D array, right? But this is not how exactly in memory the data is to be stored of 2D array. No. Because memory is, it's like a long tape of, bytes in a sequence. So we cannot store data in matrix form or tabular form. But how the data is to be stored, that I am going to show you in detail in the next video. But for now, in this video, let me just tell you in brief. This first row would be stored here continuously. Then the second row would be stored row wise. Data is to be stored. But in detail, we will discuss in next video the memory representation and accessing of the array elements, like 2D array elements, right? So this is the pictorial representation. If the array is something like this, so nothing change here. Column size is 3 and rows are 3, columns are 2. 0, 1, 2, 0, 1. Right? So in this case, suppose 3 student. So here I have student in this dimension and 2 subjects. So in this dimension I have subject. But here in this dimension I have student and here I have subject. It's okay. You can do either this or this. It's fine. Right? But yeah, first it would be row size, second would be column size. This you need to take care. Right? So this is the difference between these two declaration. Right? Now, if you want to calculate how many element you can store or how much memory, how many bytes are to be allocated for the particular array. So, if this is the case, first one. So, how many elements we can store? 2 row, and in each row we have 3 columns. Means we can store 2 into 3. Total 6 elements in this array. So, the memory manager has to allocate bytes for memory for 6 elements. And it is a float type, so each element will take 4 bytes. So 6 into 4, that is 24 byte would be allocated for this array. For this array also 3 into 2, 6, 6 into 4, 24 byte would be allocated, right? Okay, this is how I'm going to tell you, I'm going to show you, like if you want to calculate the size of these things, then we have a size of operator also. This thing practically I'll show you, right? We'll calculate the size, we'll show the size also with the help of program using size of operator. Right? This is our first program, and I'll show you with the help of program how to declare array, how to initialize array. It's okay. Now the declaration is, I think, almost clear to you guys. Now, if you are just only, if you are only declaring the array, you are not initializing the array, then you have to give both the size, column size and row size, right? But yeah, we can skip this row size. This can be empty. But that case is different, right? For now, if you are just declaring something like this, you have to specify both row size and column size. So I hope the declaration is clear to you guys, and how to calculate the number of elements and how much memory would be allocated to the 2D array, right? And the pictorial representation, how you visualize 2D array, right? How to access that in detail, I'll show you next video. Now next thing is how to initialize 2D array. So same as 1D array, we have two, methods. Like we can initialize this at compile time and at run time. So at compile time, just we give the initializer list at compile time only, and at run time, if you want to initialize, and if you want to ask the numbers, the element of this array from the user at run time, then we use loops, right? So first we'll see how to initialize it at compile time, right? Don't worry, I'll show you this thing with the help of program as well. So while declaring only like float marks 2 and 3, here only I can, this is 2 and 3. So here only I can give the data, the elements, the marks. This is known as the initializer list, using initializer list. So how you will initialize this thing, we can do in 3 ways. So first way, how many elements we can store? 3 into 2, 6 elements. So just give 6 elements. So you just give the marks. 6 elements we can store, just give 6 marks, right? So how this is going to be stored in memory. Now here, this is one thing. So first 2 rows. So first we'll take the first value, and that, like, this is the array, pictorial representation of the array. So first is 56.95. Next, in the same row, 10.2, 98.99. 3 elements, we have 3 columns. Then next row, 95, 91, like this. So this is first row, this is second row. Or one more clear way is, you can do something like this. Initializer list, let me just write down here, like this. Nested list we can use, like within this we can just have one more like list, and only 3 elements for first row and 3 elements for second row. So this is, I think, more clear way. Here we can directly say like this is row 1 and these elements would be stored in row 2, right? Or something like this also we can do, like here, just this bracket, this would be same, and in the next we can just store the marks. Then in matrix form, 91, 91, and that's it. This also you can write down, this bracket, then in next line this thing, in next line write down this thing, then in next line this bracket and just close, right? This also we can do. So this is more clear way, right? Like row 1 and row 2. So this is how you can initialize at compile time with initializer list. This is known as initializer list. Now if you do this thing, here we can skip this row size. Here also we can skip this row size. In this case also we can skip row size, because ultimately we know, okay, row size is not there, but we have 3 columns. So we'll take first element, 1, 2, 3, 3 columns would be there, that is for sure. Now if there is next element after the 3 values, so that would be stored definitely in the next row, 1, 2, 3. So ultimately row would be 2. Row size would be automatically calculated. You can skip row size, but you cannot skip column size. If you give here row size and no column size, that would be, confusing, because 56, 95, this, I don't know how many columns. So in one row I don't know how many columns are there, right? So this is the case. This would be given error, but this is fine. Sorry, this is fine. You can skip row size, right? But here if I take this example like 3 and 2, so how the data is to be stored? We have 2 columns. So this in first row, these 2 in second row, these 2 in third row, like this, right? I hope this is clear to you guys. Now if I write something like this, if this is the case, array name is A, I haven't specified row size, columns are 3 and only one value, 0, then how many rows would be there here? So 0 would be stored, 0 would be stored, 0 would be stored because there are 3 columns. Then nothing else. So this is like 1D array, right? If I write something like this, rather than this 0, I write something like this 0, 1, 2. In that case also 0, 1, 2 would be stored because there are 3 columns, but we don't know the row. So is there any element? No, no element. So this also will act as a 1D array. That's it, right? But if I write something like this, -2. Now in this case, 3 columns. So 0, 1, 2 would be stored. Next, we have an element, yes. So that would be in next row. So definitely there would be 2 rows and remaining element would be 0, 0. Initialized with 0, 0. So this is how this would be initialized, right? And if you want to store this 0, 2 in first row, 2, 2 in second row, so just do something like this. Explicitly you have to tell like this. So now this is first row, this is second row. We can clearly see, right? So here 0, 1 and 2 minus 2. So remaining would be 0, 0. I hope you are getting these things, right? Okay. Now this is like compile time initialization. At runtime, how you can initialize. So let's take a simple array. We have 2 rows and 3 columns. So we have something like this, 2 rows and 3 columns. Index would be like this. So obviously we need nested loops to initialize, to take value from the user when we use loops. So we use 2 loops. We require nested loops because 2 dimensions, so we need 2 loops. If there are 3 dimensions, we will need 3 loops, right? One loop is for rows, one loop is for columns. I have already discussed in a video the need of nested loops in C programming language, in that playlist also, and in C++ also, right? So if you deal with something like this with matrix or tabular form, obviously you need one loop to increase the row and one is for to traverse columns, right? So first row, within this we have 3 columns. So I will take I and J2 variable. So let's take I is equal to 0 and I less than, I would traverse number of rows. So outer loop would be for rows and inner loop would be for columns, right? Less than 2, number of row size is 2. Within this we have J less than column and J plus plus. And within this we can simply take the value ARR. First is I, second is J, because I is handling row and J is handling column. So first is row, second is column, definitely, right? That's it, right? So first thing, we have an element like I, we have J, so I is 0 at first, right? Condition true, yes, we will enter here. Now J is 0, condition true, yes, we will enter here. Now ARR of I, J, now I is 0, J is 0. 0, 0 means this, we can access this memory location. So whatever you will enter, that element would be stored here. Suppose I am entering -1. Now we are within this inner loop. So J plus plus, J becomes 1. So condition true, yes, we will enter here. I is still 1, I is 0 and J is 1. So 0, 1 means this location. So whatever you will enter, that would be stored here. So let's suppose I am entering 1. Like this. Now J plus plus, J is 2. Now 0, 2. So next element, suppose I am entering 10, that would be stored here. Now J plus plus, J becomes 3, but this condition is not true. So exit from inner loop, but still we are in outer loop. So I plus plus. Now I becomes 1, condition true, yes, enter here. Again J would be initialized with 0. Now for I1, first row also, this process would be repeated and 3 elements like this we can, take input from the user using loops. I hope you are clear with the funda of nested loops, right? So, but how actually these elements are to be stored, that we will see next video in memory, and how to access these elements, that also I'll show you in next video, right? Now let's, discuss this thing practically, and I'll show you programs as well. Okay, so let's create a new file here, and okay, now in main function, let's declare first a 2D array. So simple, let's take any element ARR, or if you take like float marks of, I have only like 2 subject and I have suppose 3 students, right? So this is how we can declare. And if I write here another, let's suppose int, this is another array, and suppose we have one more array. The data type is char, because type can be anything, int, char, float, double, right? So I'm taking char. So char, and just I'm taking like name 20 or 15. So if you want to calculate the size of these arrays, then we have a size of operator. I have told you, this is just the declaration. Over here, like memory has been also allocated for these things, right? So we can say it's definition. Actually, more precisely I say then it's definition, because in declaration we just declare, no memory allocation is there, but here memory has been allocated, right? So now if I want to print like cout size of array 1, that is marks, so we have a size of operator, size of, just give the name of that array, marks. And obviously if you want to print bytes as well, so you have to write down here bytes, and for new line endl, right? Same for next array and next array. So just try this out with me, right? So like this we have calculated the size of each array. So first calculate this, right? And then run this and tell your answer. Let's run this. Size of array marks, one is 24 bytes, second 48 byte, and third 15 byte. So first is 24 byte, 3 into 2 6, 6 into 4 24. Next 4 into 3 12, 12 into 4 48 byte, right? Because int also take 4 byte. Actually it depends on compiler. So in my compiler it take 4 bytes. Char take only 1 byte, so 15 bytes only, right? So this is how we can calculate the size also, we can see. And if you now initialize the array at compile time only, so equal to, here we can give the initializer list only. So this is how we can write down marks. Or second way is, if I want to write down something like this, like in bracket, so 3 rows and 4 columns, so in each row I have 4 values. So first row, let's give 4 values, right? Then this is for second row, 4 values. This is for third row, 4 values, and this is for fourth row. In fourth row I am just giving only 1 value. Sorry, we have only 3 row, right? So we have only 3 row. So in third row I am just giving 2 values. It's okay. First row would be this, second row would be this, third row would be 2 3 0 0, right? So this also we can do, right? And yeah, third, this is like simple example of 1D array. So let's remove this, right? So that is fine. If you remove this size, that is also fine. You will not get any error, right? But if you remove this, suppose here I am just removing this 3. Let's see what is happening here. See, you got a red line here. An array may not have an element of this type, right? So if I run this, what error you will get here? So in line number 5, we have declaration of marks as multi-dimensional array must have bounds for all the dimension except the first. Except the first. So first is row. You can skip this one, but other than that, if there are, here we have 2D array, so other than this we have only 1 dimension. So you have to specify this. If you have 3D array, then 1, 2, 3, 3 dimensions. So first you can skip, but other than first you have to give, for 2 you have to give the limit, or you can say that bound, right? So this is giving you an error. So let's 2, and here we have what? 3. Now you just try out the different declaration I have, told you while you were discussing this thing. So just try out all the declaration and just calculate the size of that array, right? Now how to initialize the array if I don't want to initialize this array at compile time? So if this is not the case, then you have to specify the row size here, right? Incomplete type is not allowed, right? Because we are not initializing. So how to calculate the size? Because this is actually definition. The memory manager is going to allocate memory based on this. So how to calculate how many bytes to be allocated, because there is no row size. We know the number of columns, I4, but we don't know number of rows. So how to calculate the size? Now how to allocate the number of bytes? So you have to specify. So let's suppose 2. We have only 2. Now it will not give any error. And now let's initialize at runtime with loops. So we have one variable to traverse or to hold the rows. So number of the row size is 2. So this would be like this. Now inner loop would be for columns. So obviously initialize with 0, index would be 0, less than column size is 4. It should not be like less than equal to 4. Index should be always less than the size, not less than equal to, right? Now within this, simply with cin we can take the value. Name of the array is A, first I, second is J. First is row, so first obviously this I you have to specify, next element is J. For column we have taken J, so J, right? If I run this, let's run this and see what kind of output we are getting. So it will just ask the elements. So how many elements we need to give here? See, 4 into 2, 8 elements. It will accept only 8 elements. So 1, 2, 3, 4, 5, 6, 7, 8. And that's it. It is not printing anything. Obviously we are not accessing those elements. We are just taking the values from the user. So this is how we can take value from the user, right? With nested loops. This is at runtime, initialization at runtime. So I hope till now this is clear to you guys. If you have any doubt, you can just let me know in comment section. So in the next video, we'll see memory representation of 2D array and how to access elements of 2D array, right? So now I'll see you in the next video. Then bye. Take care.